Problem of the day number 5, simplify and state the excluded values. So when you're subtracting or adding fractions with polynomials in them, everything we know about polynomials and fractions still applies. So for example, you want to factor everything out, and then you can only add or subtract fractions when they have a common denominator. So the same is true even when the fractions are polynomials. So for example, in the first fraction, let's factor out the greatest common factor of 5 in the numerator. And so in the numerator, we'll have 5 times n plus 1. And in the denominator, you'll notice that the 5, 35, and 40 also have a 5 in common. So we will also factor out the greatest common factor of 5. And that gives you n squared minus 7n minus 8 in the first fraction. Subtract, and in the second fraction, at this point, we don't really need to factor them out. You can already see that these are already being multiplied, the 7 times the n in the numerator and the 3 times the n in the denominator. So we can, for this one, automatically cancel the n on top and the n on bottom out. And so you just have 7 over 3 for the second fraction. Now for the first fraction, going back, let's factor the denominator out again. So remember, we have a trinomial where the leading coefficient is 1. So we can factor it out by looking for two numbers that multiply to -8 and add to -7. So the two numbers that multiply to -8 and add to -7 are n minus 8 times n plus 1. Okay, and in the numerator, we still have the 5 times the n plus 1 minus 7 over 3. And again, before we add or subtract, we want to make sure to simplify as much as we can first, because that'll just make our lives easier. So you'll notice that the same factors, n plus 1 on top and bottom here, they cancel out. And the 5s on top and bottom here also cancel out. So really, for the first fraction, all we have left is a 1 in the numerator, because everything canceled out, over an n minus 8 in the denominator, minus 7 over 3. And we can't add or subtract yet because they don't have a common denominator. So we have to get a common denominator first. Now, the mistake that I see a lot of people making is they'll try to just multiply this fraction times, for example, n plus 5 or something, or n minus 5 to try to make it an n minus 8. But that's not going to work, because if you think about distributing this, that'll give you a 3n plus 15. It's not going to get you anywhere near an n minus 8. So the only way to get a common denominator is basically just to multiply the different denominators together. So for example, this the second fraction doesn't have the n minus 8 that the first fraction does in the denominator. So we're going to multiply top and bottom by n minus 8. And the first fraction doesn't have the 3 that the second fraction has. So we're going to multiply top and bottom by the 3 from the second fraction. So that means that for the first fraction becomes 3 over 3 times n minus 8. And the second fraction becomes, in the numerator, 7 times n minus 8. And in the denominator, also 3 times n minus 8. And that's a good sign, because now we have a common denominator for these two fractions. So because they have a common denominator, then you can add or subtract them. So what we have now is same denominator still. So we still have the 3 times the n minus 8 in the denominator. And in the numerator, we can just subtract these. So we have 3 minus, and personally, I like to just multiply now instead of doing it later. So we have the 7 times n, but remember that it's going to be a minus. So it's a minus 7 times n. And we also have 7 times -8, which gives us -56. But because we're subtracting -56, that really becomes a plus 56. And that's another common mistake that I see, that people forgetting to change the second sign. Okay, and now that we've done that, then we can combine like terms. So -7n doesn't have any like terms, so we still have a -7n in the numerator, and then combine the 3 and the 56, which gives us a positive 59. And in the denominator, we still have a 3 times n minus 8. Now, normally, you'll see that for these fractions with polynomials in the numerator and denominator, you'll notice that the denominator, they pretty much never multiply that out. They'll always leave it in factored form, because it's never really advantageous to multiply it out. If you leave it factored, you can easily see if anything will cancel out, or if you can simplify the numerator. But so the numerator, we always multiply out, so that we can basically combine like terms here. But the denominator, we always leave in factored form. Oh, and last thing is to state the excluded value. So remember, the excluded values really come from at any point if we're in danger of dividing by 0. Okay, so the easiest way to do this is to go back to when they're in factored form. So for the second fraction, we're in danger of dividing by 0 if n equals 0. So that means that n cannot equal 0. Let's look at what else n cannot be. So let's focus on the first fraction now. In the first fraction, this is not in factored form yet, so I wouldn't recommend looking there. This one is factored, but we only factored out the greatest common factor, so it's still not very clear which values of n cannot be. And so I would look at this one right here, when the denominator is fully factored. So then you can see that, okay, well, 5 will never be 0, so we don't have to worry about that. But n minus 8 might be 0 if n was 8, so that means that n cannot be 8. And similarly for this one, n cannot be -1, otherwise we would be dividing by 0. So the three values that n cannot be are 0, 8, and -1, but otherwise, the entire fraction will just simplify as -7n plus 59 over 3 times n minus 8.